here for a few Mondays now to reimagine the definition of healthy materials and to recognize all impact categories, including circularity, carbon, water, and equity. So these have been broken out into different disciplines, and today we're here to discuss MEP systems. We do have a primer doc with some background on this topic, which will also be placed in the chat shortly if you're not so familiar with this topic. And this topic does kind of feel, at least to me, a bit elusive, especially when we consider some of the past episodes, like the interiors episode or even the structures episode, where I feel like those are really visible and tangible spaces to think about that we interact kind of in our everyday lives. But I think, you know, MEP systems are kind of behind the walls and a bit hidden. So I think it makes it more interesting and even more important, I guess, to bring to the forefront of our minds and to really understand how we can improve our material choices in this space. And here to help us do just that, we have three really great panelists. We have Bill Walsh, Ruby Rose Yepez, and Kathleen Hetrick. They'll each be presenting for 15 minutes, and then we'll have a Q&A at the end. So please think of some questions, throw them in the chat. You're welcome to take yourself off mute during the Q&A, raise your hand, shout out your questions. So I'll introduce each panelist before they present. And to kick us off, we have Bill Walsh, who I'm sure many of you are already familiar with if you've been working in the space for a while. He started the Healthy Building Network over 20 years ago, and their mission is to increase transparency in the building products industry and to reduce human exposures to chemicals in building materials and create market incentives for healthier innovations in manufacturing. He has been a visiting professor at Parsons, the New School for Design, is a fellow of the Lowell Center for Sustainable Production at the University of Massachusetts, a founding board member of the Health Product Declaration Collaborative. He has many, many awards and accolades. I won't go into them all, but he is a vet in this space. And so without further ado, I will hand it over to Bill.
Thanks, Jacqueline. And let me see if I can just share my screen. Great. Thank you very much for inviting me here today. And for those of you who aren't that familiar with the Healthy Building Network, Jacqueline did a great job of summarizing our vision and mission. We accomplish this mainly through in-depth research on building products from a life cycle perspective. Our view is it's not a green building product if it's not green for everyone who it touches, from its manufacturing through its installation use, and the fate after its intended use. To the right of the screen, you see a type of the color-coded charts that we offer on different building products and that are freely available at our website at healthybuilding.net. Oops, there we go. Tonight, I wanted to talk a little bit about the intersection of carbon and toxic chemicals and climate justice and environmental justice and how that kind of runs through plastics that we use in our buildings in very high volumes. And to get a sense of the scale of the impact of the building industry on chemicals and plastics use, until 2004, building industry was the #1 use of arsenic in pressure-treated wood compounds. Today, it's still about 50% of worldwide formaldehyde use. And of course, the second largest use sector of plastics after packaging. I also wanted to talk about this because it's a very current issue. The White House Environmental Justice Advisory Council just in May completed a report to the Biden administration, who has an interagency environmental justice council, and the recommendations of these people who are citizens and residents of frontline fence line communities living next to industrial facilities around the country included a couple of key recommendations that I want to focus us on today. First, saying that using funds to add cumulative pollution while using other funds to mitigate the impacts is a losing proposition for the communities on the ground. And a second bullet point, the Justice 40, which is the name of the initiative, must include taking bold action to sunset investment by 2030 in fossil fuels, plastics, dangerous chemicals, and nuclear energy. And I raise this because it illustrates the need for us to think, when we think about carbon and we think about our big building systems, to think about the people who are living on the front lines of our materials supply chain. That language came from something called the Equitable and Just Climate Platform that was used to frame the environmentalists' position during the presidential election, and what was invited by the Biden administration through the advisory committee process. This platform was signed on to by all the major environmental groups, the Center for American Progress, and virtually every grassroots environmental justice organization in the nation. And again, key components here that I've highlighted in yellow was the favoring of policy tools that achieve both local and national emissions reductions of carbon and other forms of pollution, and looking at policies that reduce greenhouse gas emissions and locally harmful air pollution. Why the emphasis on localities? Because as this part of the platform illustrates, there's a great concern about carbon trading and other market-based policies that don't guarantee emissions reductions in the communities adjacent to the facilities themselves, and through carbon trading schemes can even allow increased emissions in the communities that are already disproportionately burdened with pollution and substandard infrastructure. So we really want to be looking. Every organization, every company that I know of in the last year has issued a support in favor of Black Lives Matter environmental justice. A fundamental principle here is that we act on the information that those communities give us, and not on policy solutions that we develop without their input. So these are very important policy solutions, especially when you realize you can buy carbon neutral petroleum products today, right? A big emphasis on carbon neutrality is on carbon offsets. And what the environmental justice community is saying through these various policy documents is that meaningful industrial change where carbon inputs are reduced is a solution that benefits all. But carbon offsets that allow business as usual in our industrial facilities continues the disproportionate impact. So I just want to keep that in mind. The idea of offsets as somehow compensating for business as usual has been widely debunked. You can find much research on this. And this is also more than a US issue. Mary Robinson, when she was Special Envoy on Climate Change to the United Nations, framed this in a global context about the need to shift our discourse from greenhouse gases and melting ice caps into a civil rights movement with the people and communities most vulnerable to climate impacts at its heart. So I mentioned that as a foundation because we haven't quite got there in our analysis in the building industry, in my opinion. This is a typical chart. Ed Masria just presented this recently at a conference I attended, and I have no problem with Ed's approach to this. He's pointing out, especially core and shell inputs from a direct carbon emissions perspective, concrete, steel, and aluminum account for some 22%. And over in the industry quadrant, the dark gray, you see another 20% includes plastics. And this, the value here is that we can take some real concrete, pardon the pun, steps to reduce the carbon, embodied carbon of these, of concrete and steel, and really reduce the footprint of our buildings in meaningful ways through industrial infrastructure changes. But using the same source, you can see his source is the International Energy Agency, IEA. When you go a little bit deeper into their data set, you see this chart. Here, the red dots represent the direct CO2 emissions. And as you can see, cement, iron, and steel are the two top industrial sectors from a direct CO2 emissions perspective. Number three, however, is chemicals. And chemicals, as defined by the International Energy Agency, the chemical sector is driven by the demand for plastics more than anything. And so when you look closely at this, you see that the blue bars represent what's called the final energy demand, and that is the total draw of hydrocarbons of the fossil fuels into these sectors. And of course, chemicals and plastics far exceed cement and even iron and steel because they are made of oil. We also know from industry data that virgin plastics production is projected to grow exponentially such that by 2050, between now and 2050, we will produce as a global society more plastics, virgin plastics, than we've produced to date. The International Energy Agency also estimates that by 2050, half of the growth in oil demand is going to be driven by plastics. And this recent analysis, I'm not going to go through this busy chart, but suffice to say, up here in the left-hand corner, this is the recycling levels for our plastics economy in the United States. This came out of the University of Michigan. And as you can see, virtually no plastics are actually being recycled. The pink block calls your attention to the building and construction area. Abysmal rates of plastics recycling, no plans for a circular economy in plastics. And this is of great concern because when you look at the actual industry investments, you see huge investments at every stage of virgin plastics production and plastics disposal through incineration. You do not see investments, and I'm talking scales at the tens of billions of dollars in differential, maybe $100 billion differential investment in producing virgin plastics versus creating any kind of an infrastructure for a circular economy in plastics. And I raise that because as you hear presentations from the industry, from plastics and manufacturers in the fossil fuel industry, you see that there is a blurring of the line under the rubric of circularity between recycling and burning of plastics. So here you see, this is a presentation from the European Plastics Council, which talks about nearly 70% recycling and energy recovery being achieved. Now this is in Europe where they have much higher recycling rates, but as you can see from the chart, there's actually more burning of waste going on than recycling of waste. Perhaps that's just the present state and we're moving toward a better future. This is another slide from the industry presentation. And here you see they equate recycling and energy recovery, burning, as equivalent parts centering plastics as a key to a circular economy. And so we're getting the sense that recycling would always be preferred, but energy recovery, burning it, is also a great solution. And this is the industry data that kind of disturbed me the most. The headline, again, this is their slide, not mine. In general, countries with landfill bans achieve higher recycling rates. But when you look at the data in this slide, and you look at the recycling rate of Switzerland, for example, and you compare it to the recycling rates of Latvia and Croatia, for example, you see that the recycling rates are approximately the same, even though Switzerland landfills virtually no plastics, and Croatia and Latvia are landfilling most of their plastics. The difference is incineration. The difference is in burning the plastics. And that's what we're beginning to see, is that the industry is positioning itself to perpetually produce plastics as a destination for hydrocarbons that are no longer increasingly being reduced in terms of the use of fuels. And the addition of emissions from incineration, this is from the Center for International Environmental Law, only adds to the CO2 burden of the plastics life cycle and perpetuates the demand for hydrocarbons. And when we talk about burning, at every stage of bringing the plastic to an incinerator, dealing with the waste thereafter, you have disproportionate environmental justice impacts. In the US, 8 out of every 10 municipal solid waste incinerators are located in low-income communities and communities of color. So if we really want to be true to our commitments to environmental justice and achieve the ambitious objectives that are being set forth in the in the Biden administration, we really need to look at how we can have a meaningful collective impact. I mentioned that formaldehyde and arsenic were two highly used chemicals in the building industry until recently. And we've seen that together we've dramatically reduced the use of these chemicals. Formaldehyde releases from particle board manufacturing plummeted shortly after 2005. Formaldehyde releases from fiberglass insulation factories plummeted starting in 2007. Today, you don't even have to look for formaldehyde-free fiberglass bat insulation. Everything sold in North America is formaldehyde-free. Huge collective impact. Arsenic use in the United States plummeted in 2004 when the industry accepted a voluntary ban and allowed EPA to change their regulations. So this industry can have very large impacts when we take action together. And I wanted to suggest a few things that we can do to move us in this direction now. The first is, if you see products being marketed as carbon neutral, that is simply not enough upon which to base your purchasing decision from an environmental or carbon justice perspective. You need to dig down into the data and see whether the company is actually reducing their inputs, their use of hydrocarbons, their use of energy, or are they balancing this off with offsets? If you have 100% virgin building product, whether it's interior, corn shell, pipes, flooring, whatever, and it's marketed as carbon neutral, that's being achieved through offsets. That is not a circular economy, and the impacts of that product are likely falling disproportionately on communities that are already overburdened with pollution. A second concrete action we can take is to continue and expand our requirements for health product declarations. We've seen a steady increase in HPDs since they were introduced in 2012 in a pilot program. There are now over 8,400 HPDs published. We can't measure things that we don't have information about. We can't truly evaluate the carbon and toxic inputs of a product unless we know its ingredients. So we really have to expand the HPDs. Third thing we can do, I say call Tim Conway, because Tim, as many of you may know, is representative of the Shaw Flooring Company, and he told me this story over drinks one time about how he had the 800 number that's printed on the back of every one of their carpet tiles for recycling purposes. He had that number forwarded to his own mobile phone. He wanted to see how many calls he would get. He got virtually none. And that is a burden on the building owners, real estate owners, on architects, designers, and specifiers. Every flooring company, almost, don't want to be too inclusive here, most every flooring company is offering some sort of take-back program. We, as a community, need to specify products that are 100% recycled content, and we need to use these programs because what's called extended producer responsibility, when the companies will actually take back and recycle their own product, this is the highest recycling rate that we can achieve. So we need to make these programs work, and it's something that we can all contribute to for the success of these industries and these products that are piloting these programs. The third is to use third-party product evaluation. Marketing materials are not enough. Manufacturer claims are not enough. The information we offer on our website always evaluates data from a product manufacturing and chemical production perspective, as well as for impacts on occupants. It's not green for all. We don't consider it a green product. Again, this information is freely available. And then just very quickly as I wrap up, to give you a sense of how the carbon and the toxics agendas do converge. On the left is our rating of insulation products based on toxicity and environmental health concerns. On the right is a chart developed by Chris Magwood for Architecture 2030 that was looking at insulation from a embodied carbon perspective. And as you can see, our green zones are almost the same. The materials we evaluate from a health perspective are also carbon absorbing. And the materials about which we had most concern, the plastics, especially the spray foam and polystyrenes, are also identified in Chris's analysis as high carbon emitting products, increasing the carbon footprint of the building. So we really can align these agendas. There are some, oops, I actually had some additional arrows there to show you that. So we really can align these agendas. We really can take a strong step in favor of environmental justice and climate justice. We have tools that are available to us. And I hope this gives us some perspective on how we can include plastics as we try to address the overall carbon and toxic footprint of our major building materials. Thank you for your time, and I'll turn this over now, I think, to Kathleen.
Thank you, Bill. That was sobering, and I think we all appreciate the sound and tangible actions that you talked about. Next, we actually have Ruby, who is someone I've only just met, but I'm really excited to hear from more and to get to know better. Ruby is a seasoned building industry professional with over 15 years experience, specializing in affordable housing projects, which I think is a great lens to be considering reconsidering our material choices. Ruby has worked in architecture, construction, and sustainability consulting, and she holds several certifications. She currently works at Southern California Edison, and I think this is the first panelist we've had from the utility side. So I'm super interested to hear what you have to say, Ruby.
Yeah, thank you, Jacqueline. I am so humbled to be here and to go after Bill. I don't know if I can speak to the wealth of knowledge that he just shared, but I am going to talk about one little system that, is really going to help to move the market and help with decarbonization and reducing emissions as we really look at making our buildings healthy. And it's heat pumps for space conditioning, because there are a number of different heat pumps that exist out there, right? So we have heat pumps for water heating, as well as now introducing the heat pumps for dryers. So I will be focusing in on heat pumps for space conditioning today. Next slide. So just, really quickly talking about heat pumps, it seems that history always repeats itself. But, heat pumps are no new technology in the world. They actually were first built in 1855. And all of us actually already probably have a heat pump in our kitchen. I think for the most part, unless you're really rebelling and having no technology in your house, then you probably have a refrigerator, which is a heat pump itself. So we all do and are introduced to heat pumps in our homes without even thinking about it. And so, they've definitely been around for a while. Next slide. So some of the heat pump myths that I kind of want to address today are that heat pumps don't heat as well as gas furnaces, that the SEER ratings accurately portray heat pump operation. Mini split ductless heat pumps are not very aesthetically pleasing. Heat pumps cost more to install and operate than natural gas furnaces, and that the Title 24 Energy Code has changed to recognize the added value of heat pumps. So we are going to be addressing all of those items today. Next slide. So outside of my work with Edison, I am very passionate about sustainability. And I'm very lucky that I have a very proactive community-based organization in my area called Active SGV, and they recently partnered with UCLA as well as with the Energy Coalition in doing a healthy home study. And they looked at a very a DAC community, a disadvantaged community within the San Gabriel Valley, and their findings, I think, speaks to what most of us are hearing in the industry. Having gas and use appliances in the home is emitting a lot of a lot of emissions, in which it's really impacting our health. And we've never really thought about it like that before, but now we really need to take a look at that, especially that we're spending more time in our homes. I mean, how many of us were actually working from home the last 16 months or so, and being when we used to actively leave the house, and now we were stuck inside. And so we're really thinking about the appliances that we have and what they're emitting in the air, and if we are breathing in good quality air. So talking initially about the economics of heat pumps, I want to kind of dive into the cost, because cost is always the big top issue when you start talking about appliances, and what's that, what's the dollar amount that comes with it. Based off of some of the studies that have been done around reach codes, they have found, there was a 2019 cost effectiveness study done by Frontier Energy, which they found that a heat pump is on average actually less to install than a typical split system, which would typically be gas furnace. And the reason why is because two things. One is you're only installing one system, right? So the one system is serving for both heating and cooling instead of having two separate systems, as well as the operating cost of having one system is much cheaper. And you're not running the lines, you're not running gas lines to the furnace. So when you're looking at costs for building or doing any retrofit, usually plumbing gas lines is significantly higher than running anything else. So those are savings that we're seeing on that end. And then also, next slide. Oh, sorry, I forgot to okay, jump one more. The other thing about heat pumps and just overall heating and cooling systems is that, you know, the topic around high performance buildings is at its peak, and having a high performance building shell is going to reduce the amount of heating and cooling system size that you're going to need. So where we used to actually size, our rule of thumb of sizing a mechanical system was, 5 tons per about 400 square, I'm sorry, 1 ton per 400 square feet, we're not looking at that anymore, because a high performance building envelope is reducing what you actually, the sizing that you need for heating and cooling. And so combining all of, actually having a high performance building envelope with all of the code and regulation that's coming down in California, then leads, in order to create it and be as efficient as possible, you need to have a really efficient mechanical system. And so not only do you need the efficiency to be higher and better, but you also don't need as big of a system as well. And so heat pumps have actually created space for people to install systems that are smaller and that can serve a smaller load as needed. Next slide, please. So here is a really quick side-by-side comparison of what energy costs are on the time of use rate. And so the time of use rate is what most IOUs are converting all of their customers to. So many of you may be familiar with it if you haven't been converted over yet. But looking at the standard time of use, a conventional gas electric system where you have a gas furnace and then a condenser outside, you're spending about $147 on gas, $491 on electricity, for a total of $638. And with that, right now, at least for Southern California Edison, there's no special rates that you can get for that type of system. With a conventional heat pump, you're spending about $701 for electricity, but you can actually apply for the special rate, which is called the prime TOU, and you would be dropped to a lower rate, getting you at about $548 average per year. And then if you use a really super efficient system, then you're looking at about $506, and being on the time of view, you're going to reduce it even more to a little bit under $400. So even cost savings wise, there is a significant amount of, you know, extra pennies that you can have in your pocket than having to spend on utility bills. Next slide. And then this is an overall annual bill savings looking at heat pumps. So based off of the different climate zones, because within California, we have quite a few different ones, which impacts all of our energy consumption and calculations differently. So looking at PG&E territory, Sacramento, SMUD area where it gets really hot and really cold. Also looking at SDEs, you'll see that even with the highest performing heat pump, compared to, you know, just your common one, it is by far exceeding performance and cost savings. So, you know, there's no questions about what is the impact of heat pumps on bill savings. They significantly will reduce because they're higher efficient and don't need as much electricity. Next one. So I'm going to take a deep dive, or not deeper, but I'm going to take a dive into the different types of these heat pump systems that we see around, because a lot of people say, oh, I don't want one of those ugly wall units. As you can see in this picture, that's the typical when they think of a heat pump, that's what it's going to be. It's going to be this massive wall unit in the middle of my house that I really don't want to see, which is not really true. So starting off, can you skip, or sorry, next slide. Yep. So the 4 different types of systems I'm going to go through is your conventional split system. Then we're going to talk about the conventional heat pumps, a ductless mini split, and then a ducted mini split, because there's actually 2 different types. Next slide. So next slide. There we go. So your conventional indoor unit, when you're doing your split systems, you would have this massively large air handler in your attic. Or if you're like me, you have a closet with a gas furnace. And then you're going to have, next slide, a relatively large condenser outside, which you saw on the previous slide. So I actually recently converted to a heat pump, and I actually converted my gas furnace closet into a storage closet, which my husband thought that he was going to get access to, but I very quickly took that over. But either way, you could find use for this additional space that ends up happening if you retrofit. But in your conventional glass electric split system, you have ducts that are running from your central system throughout the different rooms and your condenser. You have your return air duct and all of the other different attributes that you need to have, including the flue pipe, right? Next slide. And so, oh, I'm sorry, my apologies. Can you go back to the last one really quick? Sorry about that. And so needless to say that now if you still want to go with this type of a system, if you're in California, you actually need to install a system that is low NOx if you still want to have that gas furnace. And that actually can increase the cost of installation because there's a limited supply of these types of units. You know, South Coast Air Quality District has their Rule 11 or 1011, which minimizes the amount of NOx emissions. So it is a bit of a obstacle now to try to get these types of systems as they are rolling out. But, you know, emitting this type of fossil fuels in the homes is really what the goal is in reducing the NOx inside. Next slide. So now looking at the conventional heat pump, with this, you're not having as many parts and pieces to the system. You're still going to have ducts that are running to each room, but this time you're having a smaller air handler, as well as you're still going to have the condenser outside. But these ones are still not as efficient as the mini splits, which we'll get into, or other options that are much more high efficient. I unfortunately only installed a 15 SEER, but I am still seeing savings in lieu of installing like a 13 or 14 SEER in my home. Next slide. So going on into the other 2 systems, the technology for heat pumps has significantly changed, and we now have these really high performing systems, as I mentioned before. So they're not your typical grandfather's heat pump by any means. Next slide. So as I said, the ductless mini split is the one that people most commonly know when you hear the term heat pump, and it's this massive wall unit that you typically think of what you're going to put in your home with a smaller condenser outside. And that doesn't necessarily mean that that is what you have to move forward with if you do want to have a mini split. There are also what are called cassettes, which are more aesthetically pleasing. Next slide. So with the ductless mini split, as you can see, you don't have the full blown duct design that you would have to have with a ducted system. You're just having these minimal refrigerant lines that are running to each different, in this case, wall unit in each room that you have, or whatever zone you're going to be having. And it also makes it a little bit easier to zone the heating and cooling spaces within the home, in which that can also contribute to reducing your energy usage, because you're only heating and cooling the space that you are within that time frame. And, you know, as you move from room to room, then you can heat and cool it as needed. Next slide. So as I mentioned, there's different types of mini splits, and there's definitely the wall unit that everybody's most commonly aware of. And then there's the cassette, and the cassette can go into, you know, a drop soffit or up into your attic space to not be so, it has a better eye appeal than having this massive wall unit in the home, and along with your package unit that would be outside. Next slide, please. Then we have the ducted mini split system, which is kind of going back to your traditional system. But in this case, you may not need as many actual ducts in the home, and your registers can be a little bit more smaller than your normal vent sizing. These typically are located within conditioned space, and so you're not being exposed to the high temperatures that usually exist within the attic space, and can make it a little bit harder for your HVAC system to keep the air cool or keep the air warm, depending on what the temperature is outside. But the most painless option for California builders, because the appearance in the home is no different than traditional split systems, and first cars are similar to the split system. So it's easy to transition from a regular traditional system than actually using this type of mini split ducted system. For some reason, many people are still very attached to HVAC ducts and are unfortunately still not comfortable with refrigerant running through the lines yet. Next slide. And as you can see in this photo, here are a couple of different flexible mini split configurations. So you have your ceiling cassettes, you have your regular vent or register, and then on the last picture on the right, you could see a directional air louver. I've seen quite a few of those happening a lot in the modular homes. That's what they're installing for many of them in that space. But those seem to be a lot more efficient when you're designing these types of systems, especially when you have a very tight envelope or wall space that you're trying to, wall cavity that you're trying to fit all of your different wires through. So that works a little bit easier. Next one. And then ducted mini splits, the benefits of the ducted mini splits are, you know, they, like I mentioned, they're very high performing. They're listed on the AHRI list of high performing technologies. They have ducts and air handlers located typically in conditioned space, like I had mentioned before. They keep really high comfort levels. They have exceptional air filtration and small particle remover, mainly because your filters are a lot more condensed, and so the amount of air particles that are coming into the home is minimized. They have a really nice appearance for the most part. They're not your typical registers that you're seeing up above your doors. They have different options, and the biggest thing with that is they have a very, very low noise level. I recently was out visiting a home in which they had a mini split right by their battery system, and right next door was this other home that had this massive 5-ton condenser, and it was so loud. And I put my ear to the mini split that was at this home, and you could barely hear anything, whereas this other massive condenser was just like pumping out air and being as loud as as loud. It was just loud. So the noise level is also one of the things that I really like about it, mainly because it's outside of my daughter's room and it doesn't wake her up every time it turns on and off. And then ducted mini split heat pump capacities can now match new enclosure heating and cooling loads. So this is speaking to the fact that, like I said, high performance building envelopes don't need as much heating and cooling in that space. And so you can get away with your 3/4 ton or 1 ton systems because they don't need as much heating and cooling coming into that space. Next slide. And then some of the really super efficient systems include the variable refrigerant flow and variable capacity heat pumps. These have significantly higher energy savings, but they also do have higher upfront costs, unfortunately. These can be either a mini split, deckless, or ducted systems. They do monitor the outdoor temperature, the indoor temperature, and the temperature set point. So that's how it kind of modulates itself. It also modulates a refrigerant flow and airflow to operate as efficiently as possible. So typically they're running continuous, and they usually on a very, very low speed when it doesn't need to be pushing out as much air to heat or cool the space. So these ones are usually running continuously to help manage your energy load of turning on and off. Next slide. So the variable capacity heat pump, this is what I was speaking to. The quality for heating and cooling credit, you get a significant amount of credit on your energy modeling or your energy report if you do have a variable capacity heat pump. And again, that's because the amount of energy that it takes to turn on a system is not necessarily being used because it's continuously running at a very low level. And it could be up to 60% more efficient. Next one. So when it comes to talking around decarbonization, heat pumps are obviously the technology that is the go-to right now for if you want to do the all-electric pathway. There was a study done by E3 in which they defined beneficial electrification or strategic electrification is replacing direct fossil fuel use with electricity in a way that reduces overall emissions and energy costs. So by replacing traditional gas furnaces and gas and electric split systems with heat pump HVAC technology, this is helping that effort. Also some additional studies that were done by UC Davis at their Lighting Technology Center. They also found that single family homes built with the 2019 standards will use about 7% less energy due to energy efficiency measures than the 2016 standards. But also this will help to reduce emissions by 700,000 metric tons over 3 years, which is equivalent to taking 115,000 fossil fuel cars off of the road. So buildings definitely are playing a significant role in helping us to reduce emissions and clean up our air. And the last piece with regards to heat pumps is the role that they play within the energy code. So before the 2019 energy code, which went into effect on January 1st, 2020, the energy code basically would ding you if you were using an electric type of technology for heating and cooling because gas was seen as the less expensive. But in this case, now that we're looking at the impact of emissions, the 2019 energy code actually allowed a level playing field between all electric pathway and the dual fuel pathway. So now if you are modeling a building with that is all electric, then you're being compared to an electric baseline in lieu of being compared to a dual fuel baseline, which has been a significant change because there was a number of stakeholders that were trying to push all electric technologies and buildings, and they were having a hurdle because of this, this code impediment. And so now a lot more people are able to move forward in that space. Next slide. Um, Also, the biggest thing is with regards to the indoor air quality is not only just the efficiency of the system, but also the filter itself. So, you know, MERV 13 kind of was the minimum that a lot of them was not pushing, but now with the MERV 13 filters, this is allowing for less particles to come into the home using these types of systems, and they perform well with it. You can't necessarily slap a MERV 13 filter on an old conventional type of system and it's going to totally throw it off whack, whereas these higher performing efficiency systems, as the heat pumps are, can work effectively with these types of filters to help keep, you know, the airflow in the home as clean as possible. Next slide. And then with regards to the overall score, if you are using a variable capacity heat pump, as I had mentioned before, you actually can get a pretty significant credit of probably about 12% on your energy report to meet compliance. So if you're taking a ding on, you know, you might have a massive amount of west facing glass, or you really don't want to put on that rigid insulation on the exterior building envelope, you could potentially gain a credit enough to offset that with if you install a variable capacity heat pump. There's a pretty significant savings with that. And last but not least, heat pumps is no new technology. The rest of the world is doing it, and California and America need to get on board with it. Europe represents about 70% of actually having heat pumps, and Asia is roughly, you know, about 90%. So, you know, there's a lot of other countries that are using this technology. We just need to be okay with using it here and changing the conversation around the gas industry. And that's it.
Thank you so much, Ruby.
Welcome.
You've sold me on heat pumps. It is surprising how this really doesn't feel like a space that's talked about a lot. And we're starting to discuss it at our firm. So it's great to hear that you are too. Next up, we have Kathleen Hetrick. I could probably spend the rest of the session talking about Kathleen, but I won't. She is a senior sustainability engineer at Buro Happold and a Bloomberg Masters of Public Health Fellow at Johns Hopkins University, just one accomplishment on a very long list. As part of Buro Happold's sustainability and physics team, Kathleen combines her passion for human-focused sustainable design with a technical background in mechanical engineering. She has experience on a very wide range of cutting-edge projects across all scales of work, including LEED Platinum projects, Living Building Challenge projects, historical adaptive reuse, LEED neighborhood developments, and city and campus sustainability plans. She is a force of energy, and I cannot wait to hear what she brings to the table.
Thank you very much, Jacqueline. It's great to follow. Can you guys hear me? All right, it's hot in LA, so I've got my fan on. Can y'all see this? Okay, cool. Yeah, I mean, it's so amazing to follow some of my heroes. Ruby and Bill are just, you know, have done so much for, you know, our industry in California, but I think, you know, thinking about health and climate justice equity, you know, within their own communities and, you know, outside of that. And I think, you know, when we were talking about setting up a healthy material series, we wanted to include building systems because, as Jacqueline says, it's usually something that's so hidden from us, even though it's kind of included and has been included since in the 70s in terms of energy efficiency. But, you know, there's kind of there's another story that we need to tell, and it combines elements from what Bill was talking about and also what, you know, Ruby was just saying. So I'm gonna, hopefully you guys can kind of play along with me and see, you know, health justice, climate justice, operational energy, all of these issues coming together for us as a sustainability industry. And I just wanted to start by kind of giving you like maybe a little bit of a geographical tour and thinking about back in time to, you know, the environmental justice movement, they say in the United States, you know, really started kind of at the tail end of the you know, in the 80s and the 90s, and it started in a small community in North Carolina where a predominantly Black community that Warren County, the PCBs, which are very, very harmful materials, carcinogens, they were getting, you know, dumped into a landfill in a community. And those PCBs, part of the reason they even exist is for the transformers in our electrical systems, right? So you can see at the very start of environmental justice issues, our building industry, we're a key component of that. If you guys remember a few years ago in London and Kensington, there was the Grenfell Towers of affordable housing development, and the fact that, you know, the design and construction team decided not to go with you know, better performing materials. When those materials caught fire, not only did it end the lives of so many people in the facility, but also, you know, throughout the community was contaminated by hazardous chemicals like benzene. You know, it's another issue of, you know, environmental justice in the construction industry. And then, you know, to this day, we're seeing massive worldwide protests from large, you know, conglomerates like Bill was talking about in terms of plastics, where people are seeing health issues like endocrine disruptors, which are messing with their children's hormones, or you know, causing fertility issues, or causing, you know, rise in cancer rates in Louisiana. So, and you know, I'll know a big source of those plastics, like Bill was saying, is the plastics and the petrochemicals within our community. You know, the PVC in our piping that we put in. So, anytime you hear the word environmental justice, I do want you to think about the construction industry and our role in that. And, you know, I know you've probably been hearing a lot about our friends in South Africa and you know, the struggles that they're going through currently with the mass protest over inequality. And we actually had someone, a good friend of mine, speak at the beginning of this series about Durban and South Africa and issues of inequality there. But it's very similar to what we're seeing in Los Angeles. The photo on, you know, the left side of the screen is in Wilmington in Los Angeles County, right by Long Beach, and you can see the refinery in the background right next to people's homes, people who probably don't have MERV 13 filters or don't have HVAC professionals or well-certified buildings. And you can see even the similarity in the architecture, right? Similar climate, similar inequities, and similar locations of being right next to a petrochemical refinery that, you know, allows us to have the building supply chain that we use to build our buildings, right? So it's a local issue and it's a global issue. And maybe you know, you can say, oh, that's all very important, and thank God we've got the NRDC or we got Bill to take a look at that issue. And you know, as long as we design efficient buildings, we're doing our part. But I'd like you to kind of consider, you know, if you're a mechanical designer, if you're working in electrical engineering or plumbing engineering, or if you're an architect and you've got some of those folks as subs, or you're a contractor and you build these systems yourself, think about your own projects, right? A duct, my background's mechanical engineering, and the ductwork that I designed for the first couple of years of my career, it's not just as simple as, you know, a steel rectangle or a tube, right? There's the insulation that we need to keep it efficient. There's the mastics and the adhesives. There's like a whole bunch of, you know, stuff that goes into our ductwork. And, you know, if we look really closely, like we have to do on one of our Living Building Challenge projects, we realize that within a closer look, you know, that insulation isn't at all what it seems. We don't have, you know, the adhesives somehow slip past the typical lead review that we do for VOCs. There's a lot of hazardous carcinogens, endocrine disruptors, chemicals that lead to asthma, and they're in our ductwork, right? That's a big issue for, you know, us as a population when we're so concerned about healthy air. But, you know, there's small amounts. You know, we can say, oh, I can sleep at night. I'm doing this. This is a completely legal job. I meet the regulations, and you know, we've never heard any issues with people suffering from bad air quality, right? You've never heard that. But it's not just the source points, you know, it's not just the thousands of linear feet of ductwork that we install in buildings every year, right? I know for myself, I work for a global engineering company, and I don't even know how many buildings we design every year across the world, but you know, that ductwork adds up. You know, as Ed Masrier likes to say, it's a huge carbon footprint. And, you know, as Bill was alluding to, it's a big health impact. So if you're working for a small architecture firm or a large engineering firm or a massive construction firm, these things add up, right? We've got large portfolios, or maybe you only work on local portfolios and you can make a difference that way. And it's really important because, you know, these small amounts of materials add up. And for the United States, just looking at the United States, you know, we contribute to all sorts of toxic releases, things like heavy metals like zinc and lead, the chromium that we use for steel manufacturing, the methanol and the formaldehyde that goes into our insulation and our carpeting, all of the vinyl, the chlorinated materials that go into our plastics. These all add up somewhere, right? Maybe we don't necessarily live next to manufacturing sites that, you know, spew out these emissions, but they're happening somewhere in the United States and all over the world. And of course, you know, with the United States, there's a rural and an urban divide here, right? We've been able to, me either, man. But you know, the issue of the rural and urban divide, right? We've been able to use, you know, great change and codes that protect us from industrial pollution in our cities. But if we look at the on-site emissions population burden in terms of toxic pounds per person, we're seeing a growing issue where a lot of our industrial pollution is getting outsourced to rural communities. And these communities are typically poor and communities of color. Part of that is similar to what happened with redlining. You've probably all heard of that. But, you know, sometimes it's just, you know, where these industrial facilities can be sited. They're not going to be sited in downtown Los Angeles. They're going to be, you know, at the source of where we have our ports and where we have, you know, our oil and gas infrastructure. But it's not just the rural and urban divide. We can look at our own cities, right? This, the image on the left is Southeast side Chicago. This is using the environmental justice EJ screen from the EPA, where you can take a look at which communities are, you know, environmental justice communities that fall into socioeconomic issues and also are predominantly communities of color. And then that overlays, you know, how close are they to a Superfund site, which is, you know, the most toxic, you know, sites that we have from like the 60s and the 70s. You can look at the cancer risk. And so many times we can look at, you know, which communities are dealing with pollution, and a lot of the pollution that they're dealing with is historic pollution brownfields from old steel facilities or old landfills that used to take, you know, our construction waste. So our historic issues that we're still trying to recover from are related back to the construction industry. And I remember back in 2020 when President Biden, he wasn't the president yet, and he was in a debate with current President Donald Trump. And at one point during the debate, he started talking about, he said the phrase frontline communities. And he made a reference to Marcus Hook in Delaware, near where he's from. And he talked about the pollution impacts of communities as they're exposed to refineries, different types of manufacturing, vinyl facilities. And you can Google Map, you know, feel free to open up your browser, type in Marcus Hook, and you can see an elementary school right next to, you know, some pretty terrible industrial wastelands. And, you know, I feel for those kids. I feel for those communities who are living right beside it. And this is sadly not an issue that you hear a lot at Greenville, or you hear a lot at the ILFI net zero thing, you know. So it's something that we need to be talking about. And as we're thinking about embodied carbon issues or operational carbon or climate justice or healthy materials, we really need to think about who's getting impacted. I think Suzanne and Melissa last week were talking about this. Is, you know, it's for so long we've really been focusing on like the building user. What is the health impact for them? And it's a very important thing to think about. You know, things like well certification are very, very good progress, but are we thinking about the fence line communities, the frontline communities who have oil and gas wells that, you know, eventually become our paint, or eventually become our pipes, or eventually become our insulation? Are we building for them? Are we thinking about those communities? You know, are we thinking about the manufacturing workers who, you know, they end up with, they used to have asbestos, you know, issues, and now, you know, they're getting exposed to large amounts of formaldehyde or to ethyl benzene. Or, you know, my brother's a firefighter, and when he joined the force, the guy in the firehouse that he was joining, there was a fire in a gym, and the polyurethane insulation caught on fire, and because of the chemical reactions with that flame, the high flame and the gases that are created, one man perished and another firefighter will be attached to an air supply for the rest of his life because he suffered from high hydrogen cyanide gas poisoning. And that's because of choices we made as an industry. MEP engineers, architects, builders, owners, we made those choices. And maybe we didn't choose to see, or we didn't know, but there's a lot of information out there to some amazing people like Ruby and Bill that we need to listen to this information because we can really save some lives and do some good. So every time that you hear folks talking about embodied carbon, maybe you're running an energy model, we really need to be thinking about how can we center health and center health for everybody, right? From the whole life cycle through extraction to recycling. We really are going to have a circular economy. We need to be thinking at all these issues. And I know it's a really tough thing. We've all got very busy, stressful lives. But I think, to the sides that Bill started us on, like, we have a huge impact. We can really do something special within the construction industry if we think about these issues from the beginning of our projects, even before, and thinking about, maybe that's using one of those cool new tools like EC3, and we can look at the embodied carbon footprint of a material, but maybe then we can also use mindful materials to check out, which of the low carbon options doesn't have formaldehyde or doesn't have vinyl in it. There's so much information that we can use, and it's really for us to start thinking about, it is my job. It is my job to lower a building's operational carbon, choose a low carbon material, and think about human health. I mean, we're smart folks. We have the tools to do it, and we really need to think about that in every project that we work on. And I just would want to end here to think about, we've got, if you work for a company and your company talks about equity, or you talk about Black Lives Matter, you talk about, you've got a just label, or maybe you don't, maybe you have a diversity and inclusion form, maybe you, whatever, we all probably work for companies that have that kind of thing. We need to think about where insulation manufacturing is happening. We need to think where our building products come from, because most of the time they're not coming from a nice neighborhood like Santa Monica in Los Angeles. They're coming from communities that already have their fair share of pollution. We need to, start reaching out to communities that are fighting, especially in Los Angeles and San Francisco. California has terrible setback laws. You could have oil and gas drilling right next to someone's home. We should be working with communities to understand what their problems are, and we really need to question why we haven't been working them in the first place. We also need to consider, the pollution that comes from shipping glass from Europe, right? Sure, it might have lower embodied carbon, and you can do that dance and get your lead points, but that pollution has health, that carbon pollution has health impacts too. So these are all things that we need to think about. And I guess to leave it to my MEP engineers, like my brethren, I guess, like, we design buildings to, have MERV 13 filters and carbon filters, and we think about, doing our ASHRAE ventilation questions. But the communities that don't have, they don't have any way to protect their air, whether it's from wildfires or from a refinery explosion. We need to think about, who gets access to clean air and who doesn't, and who gets to live in a well-certified building and who doesn't, and who do we really serve, whether we're architects or engineers, what communities are we serving? So I think that's a really important thing to leave y'all with, and I'll stop there. Thanks.
Thank you, Kathleen. I love how you connect the dots for us and really make us see the connections with our work. I'd love to start off the Q&A with asking each of our panelists some key takeaways that they had from each other's presentations, and I'll start with you, Bill.
I guess my key takeaway is the potential. We have such great potential and alignment through so many sectors of the industry pulling in the same direction. And so I think that's the most promising thing to me. And also in places like LA, there have been forums where we've seen working around the idea of climate action plans in LA. You have had the utilities at the table, the same table convened by the city, along with the building industry and environmental justice groups who are living adjacent to oil and gas wells and manufacturing facilities. And I think that's the kind of process that we need to aim for, and it becomes reflected in the LA plan. You see goals for reducing pollution in the neighborhoods, the industrial neighborhoods, alongside goals for more energy efficient buildings and health standards. So so my takeaway is that we have a lot of kind of stars aligning to help us do a better job and really make sure that we have equitable outcomes, and that starts with process and engagement. I also say it's not easy. It's not easy to really get meaningful and scalable metrics from industrial communities. What can we really do in the building industry that makes a meaningful difference in a petrochemical community in Texas or Louisiana? But I think that coming out of the Environmental Justice Advisory Council and the Biden administration's commitment to invest more heavily in achieving environmental justice in industrial communities, we are going to finally see some standards that we can hold our supply chains to. So that's my quick take on that.
Thank you. Ruby, I'll go to you next.
Yeah, I mean, I think there's no denying that this is a social justice issue, and climate equity is really the goal that we're trying to achieve here. And just as Bill kind of had mentioned, you know, it's a collective effort. And I think at this point, our voices as designers, and you know, if we're on a design team or we're helping within a project itself, our voice matters. And there's so much unlearning that has to happen within this space and how we typically design, and then relearning. And we need to not be afraid of using our voice to educate our clients, because a lot of it, usually direction comes to them. Okay, this is what I want, and you want to move forward. But honestly, at the end of the day, these are buildings that are going to reflect the work that we want to push forward, and we need to use our voice to speak to it. We do a lot on our end as being consultants or as being designers, to educate ourselves on what really we should be using and pushing forward. And we shouldn't get scared when the client might want to push back, and we can push back harder, but just be able to create the resources and the tools to develop to be able to educate builders and developers to really understand the value of this. And it's really an industry movement in order for it to push forward. I mean, even with just the simple technology of heat pump, there's so much pushback just on that one little technology, right? But it has such a huge impact in moving things forward when we talk about the spectrum of decarbonization. And so I'm really big on walking the talk. That's why I put in a heat pump in my own home, and to really be able to speak to, yeah, this is what I went through. This is what the process was. And, you know, there's so many different intricate pieces that go into when you replace a mechanical system, including now, you know, when it comes to HERS testing, if you're dealing with residential projects, or, you know, just assessing the system overall. But you know, I wanted a specific type of technology. And one of the biggest hurdles that we're seeing is that there's a lot of trade skills that lack in being able to do this type of work. Then my next step is a heat pump water heater. God forbid, I'm going through the process of trying to find a plumber that knows how to do it. And there really isn't a lot of stock of plumbers that know how to do that. So we need to put a collective effort to be able to educate and train and really give value to what it is that we're asking for, to these types of technologies, to cleaner materials, to cleaning out, you know, the whole entire, you know, life cycle of our materials. We have to keep asking for it, because when we stop asking for it, that's when it's not going to get pushed forward. And so in our role, I would say my biggest takeaway is and in your roles, I'm not a designer, in your roles as designers and being in this active space of giving, influence to what's going on in your buildings, use your voice to move things forward. So yeah, that would be my key takeaway.
Thank you. And Kathleen?
Yeah, I mean, I think that's the incredible thing. I guess when I started my career, embodied carbon was kind of like in like 2013. It was, maybe it's something that people kind of threw out as an idea, but maybe didn't stick, or like a net zero heat pumps and decarbonization. That language wasn't there, and then you've kind of seen the trajectory, like the hockey stick of just we've got conferences on these issues, we've got like heat pumps in the code, people dealing with the intricate issues of like Title 24 not giving you credit for heat pumps, or like Bill talking about HPDs going from 0 to 8,000. And I think that's the root. Sometimes I think it can feel a little depressing, you hit a roadblock with a project, but then I think there is potential for us to really make a huge difference. And I think our industry is one that maybe has the most, and maybe the most impact of all the things that we could be doing. We can shape cities, we can shape code, we can shape regulation, we can make our own choices using, cleaning up our specifications, or telling your lunch and learn that you want to hear about heat pump technology and not about boilers anymore. There's just so much potential. And if we focus on the right things, if we focus on justice, I think we've got a shot, and it's a really hopeful, I guess, like listening to Ruby and Bill, I'm filled with hope, because I think that there's a way for us to really get this right, and we don't have a lot of time, but I mean, seeing embodied carbon really take off, we can get a lot done in a little bit. So that's just feeling hopeful, I guess, is my takeaway. I'm usually doom and gloom.
Yeah, I think I'm going to continue on that trend. We've talked a lot about barriers and obstacles, and I think we should maybe shift the focus here and talk about some successes that you've all seen in this space, and maybe a project that you've worked on, or one that you've heard about, a specific material or a tool. I'd love to kind of go straight into the successes. So whoever wants to jumpstart that.
I can speak to that. I would definitely say, within the realm of the work that I do, the energy code, as much as it pushes and at times creates barriers, it's also helping us in moving certain technologies forward. And just going back to the heat pump, like I mentioned earlier, they are giving a significant amount of credit for, high efficient types of systems. So there is definitely a win when it comes to situations like that. Same thing as far as, when we were trying to move solar in the market, and now we're trying to move battery storage in the market, seeing that the code is allowing for credits to be given for those types of technologies will definitely help to move it forward. And then just, overall legislation, if we're able to get certain things into legislation and move it forward, then it really helps. Look at this. Now California is, all new vehicle stock needs to be all electric by 2035. When would we have ever seen that? But now it's sooner than later. And so continuous engagement, as much as I don't like to engage in politics, but continuous engagement in that sector and continuously moving and asking for stuff will also help move forward. But getting code that will align with the work that we're trying to do is a win.
On chemicals, another success story that I didn't mention in my presentation because I don't yet have a nice chart that shows a cliff dropping off production, but it goes to a softener that's often used in vinyl products, especially soft vinyl products, a chemical called phthalates, which are associated with endocrine disrupting activities and have been banned in children's toys, for example, in the United States. But the building industry has now seen a virtual elimination of those softeners in vinyl flooring and in vinyl wall covering. And that was done without any regulation. That was done because of the demand side of architects, designers, and building owners. Until the day they stopped using those chemicals, the flooring manufacturers were defending them, and then they were gone. So that just shows what the power of the market can be. Speaking as consumers, speaking as high volume or high profile purchasers, to say we really don't want these chemicals or we're going to avoid that product. That made my job a lot harder, because I think the vinyl products should not be used anyways because of their overall life cycle impacts. But at least we did reduce some of the occupant exposures to known hazards with no regulation.
I would say for me, we were able to learn a lot in my office at BH, because we did a living building challenge project, and we had to set up a process to look at the hundreds of materials that are associated with an office building. And if you have to look at all of those, from the red list materials, no formaldehyde, no PVC, it seems like a really difficult undertaking. And I think everybody was worried about cost, and eventually everybody like pointing fingers, but that didn't happen. We all kind of put our heads together and said, we've got a job to do. And we got the contract, the Hathaway Dinwiddie, the contractor, was really on board with it. They got it into their process. All of their subs got into the process. The architect, Frederick Fisher and Partners, even the city of Santa Monica, and then us on like the sustainability and MEP side. And what we learned by just kind of creating a process for looking at our submittals and looking at what we're actually putting in a building, it's a very similar process that we're doing for embodied carbon to make sure that we're following through on our designs. And I think that a lot of people, there's probably 100 people involved with that project, and they probably all had a fear of the red list and having to deal with materials, and it was kind of unfounded. We were able to get a beautiful building, have biophilic design, do everything that we needed to do. And I think it's not as scary once you dive in and say, this is something we're going to accomplish. So I think putting your minds to an end goal to think about the materials that you specify, that's been a big one for us. And I think a big one for an industry. The more living building challenge projects we get, but the more buildings that just look at embodied carbon, we're going to see a reduction in toxics, just because those two things go hand in hand. So yeah.
Thank you for that. I'm aware that we're running up against the clock, so I'll ask one more question here. And I think, we've been hosting this series for a number of weeks now, so I think I'm eager to hear kind of specifics on tools and resources that you would all recommend to us when we're embarking on projects, and kind of have a network of support to back up decisions around healthy materials. I think that would be really helpful for the group here.
Well, I just let everyone know that on our website, healthybuilding.net, we do have the product guidance in a color-coded fashion for 10 different product categories. We're not dealing with specific brands. We're dealing with product types and giving you a cut across their environmental hazards and chemical hazards. And again, looking at it from the life cycle perspective. So we do our best to take in data like toxic, some of the stuff that Kathleen was referring to, the toxic released inventory data of the manufacturing supply chain. And it's not nearly perfect from an environmental justice impact point of view, but we're constantly refining that. And then secondly, I think the HPDs are critical for us to understanding more and more about not just the end product, but the supply chain. And there are new tools within the HPD builder online that allow manufacturers to get more information about their supply chain in there. So those are, and I know that this information can be intimidating to an architect or a designer. I'm not a chemist. I can't say half of the words of the chemicals that I'm concerned about. But like me, what you're doing is you're contributing to a body of knowledge that the many chemists on our staff, chemical engineers, and other people can use in order to formulate new standards and give us kind of simplified evaluations of products. And yet, for those of you who like that kind of stuff, you can pretty much click through our website to get from the color-coded guidance to the original data, if you'd like. So, and we welcome anybody who wants to do that and check our work and propose better ways of being more accurate or comprehensive. And then we're always looking at how do you reduce the use of the chemicals. We look at it on a use and input basis rather than an emission basis. Not that low emissions in the built environment isn't a good objective, but it's when you really eliminate the use that you hit on all those points that Kathleen was touching on in her life cycle slide. And so that's where the red list comes in as very effective. But I think we're getting to the point now where we've gotten a lot of the low-hanging fruit on those red lists, and we need to kind of amp up the engagement with the manufacturing community to provide more alternatives and fewer exemptions on the red list. So I think that's another resource that the red list from Building Challenge.
And I would say, if you feel like you can do anything on, equity in your projects, I would share that. I don't know if you can see my screen, but if you just go to EJ, if you just like Google EJ screen, it's environmental justice screen. It's a EPA tool, and you can do, if you're you're working in San Francisco, you can look up different environmental indicators, different demographics. You can look at like race or socioeconomics, but then you can kind of, if you do the EJ indexes, it overlays them so you can see, which communities that you're working with are at risk for, in the highest percentile for cancer, for like, you can see like Richmond compared to like the city of San Francisco, they're really close to a lot of hazardous waste or a lot of Superfund sites, or even, if you're working in a community and there's a lot of lead paint, historic lead paint, I think it's something that I would say is free and it's pretty easy to understand. And if you're starting a project or thinking about what kind of work you want to do, it's a super easy way to just get into the idea of thinking about public health and where do we build and what are the impacts that our communities are facing. So that is definitely kind of like a low-hanging fruit that I would recommend as a tool, is EJ Screen. And there's also a California specific version of it if you want to check that one out.
I would say on my end, since I work for a utility, actually, most of the utilities, actually all of them, all of the IOUs, PG&E, SDG&E, Edison, and SoCalGas all have energy education centers, and they offer an exuberant amount of free education on what their agenda is. And Edison does offer a number of trainings on clean energy technologies and design that will help support all electric buildings. The RENs, Bay REN and 3C REN also offer some really amazing content as well in this space. So those are free trainings. A lot of them used to be in person, but now, given COVID, they're offered virtually, which has really expanded the network of people who can actually attend and participate. So that's a really great resource to look at as well. And I know that USGBCLA has been doing some work in this space in connection with some of the AIAs as well, and just trying to develop the resources. So, where there's a need, if it's brought to typically an IOU's attention, they could find a way to hopefully support it and develop whatever is needed in that area. So just, putting that out there for anybody who has some great ideas on resources and tools that, they need some help with developing.
That's great. Thank you, Ruby. I didn't know about that first one that you mentioned. And in the remaining time, it would be great if we could just get closing remarks from each of you. So start with you, Bill. You each have 30 seconds.
Well, thanks for the opportunity to make the presentation. And for anyone who's interested in the topic or deeper dives on the intersection of embodied carbon and toxics, I'm happy to send this presentation out. I'm happy to talk with you personally. And we're always looking for more people with interest in deep materials analysis. So just let me know your interest and we'll start working together on something.
Ruby?
I think that the biggest way to make impact is walking the talk. So practice what you preach and don't be afraid to use your voice, because your voice can go a long way. And if your voice isn't going a long way, then find a group of people to put your voice together and use that. And thank you for inviting me. I'm very humbled to be here with two amazing other panelists. So thank you.
Thank you. And Kathleen?
Yeah, I think to summarize, you know, I don't think a lot of us, you start your first job and you might feel like you don't have a lot to contribute, or like you don't have a voice, or, you know, it's a big industry out there and there's so much in the world of sustainability. But I think that there's so much that we can do as individuals to create like a sea change within our communities and within our industry. And the more that we talk about these issues, and the more that we kind of get engaged with what communities are facing and, you know, how that contributes to climate change in general, I think the, you know, the more that we'll enjoy our jobs and the bigger impact we'll collectively have. So yeah, it's being passionate about really interesting topics that can do a lot of good in the world. So thank you all for joining us on a Monday. It's really awesome.
Yeah, thank you everyone who joined. Thank you to our incredible panelists, and please join us on August 2nd for our last panel. It's going to be on tomorrow's materials, and I'm sure it's going to be just as fascinating as today's was. So thank you everyone, really appreciate it. See you next time.
Thank you, Jacqueline. Thank you.